Now let us, dear students, now let us prove this theorem related to the circuit matrix and the incidence matrix of the digraph. Let G be a digraph without self loop, and A be the incidence matrix of the digraph, and B be the circuit matrix of the digraph. Now suppose that the edges in the circuit matrix and the incidence matrix are arranged in same order, then we have to prove that the that AB transpose is equal to 0. That means every entry in AB transpose is equal to 0. That means AB transpose is a 0 matrix. So let us start with the proof of this theorem. Let the vertex set of the digraph G be given by V1, V2 up to Vn, and the edge set of the digraph be E1, E2 up to Em. Suppose that the digraph G has Q circuits, then in that case the order of the incidence matrix will be N cross M, and the order of the circuit matrix is Q cross M. And so the order of AB transpose in that case will be N cross Q. Now note that A matrix is given by this, and the B transpose matrix is this. Thus now applying the transpose, we have this. I have only written the ijth entry of the A into B transpose. Thus the if I fix I with 1 less than equal to I less than equal to N, and J with 1 less than equal to J less than equal to Q, then the ijth entry of the AB transpose is given by this. The ijth entry of AB transpose is this. That is the ith column of this matrix, and the ith row of this matrix, and the jth column of this matrix. So this is the ijth entry of AB transpose. Now I have to prove that in any case the ijth entry of AB transpose is equal to 0. Now consider this first term AI1 BJ1. Then AI1 is this entry and BJ1 is this entry. Now AI1 is non-zero if E1 is adjacent to is incident on this vertex Vi. If E1 is not incident to the vertex Vi, then this entry is 0, or else this entry is non-zero. And therefore A1 is non-zero if E1 is incident on Vi. But if this E1 edge is not in Cj cycle, then also this is 0, or if E1 is in the Cj cycle, then this is non-zero. That means the first term is non-zero if E1 is incident on Vi, and the same E1 is in the Ej cycle also. That means, again I repeat, the first term of this equation, the first term of this equation is non-zero if E1 is incident on the edge on the vertex Vi, and the E1 same edge E1 is in the circle in this cycle Cj also. Then only the first term is non-zero. That means in fact every term is in fact if this if I consider the second term, then if E2 is incident on Ei and the same E2 is in Cj cycle, then the second term is non-zero. So the same is true for every terms. So if none of the edges Ei's which are incident on the vertex Vi is in the cycle Cj, then all the terms are 0, and therefore the addition will also be equal to 0, and therefore the ijth entry of AB transpose is 0. So in that case we are done. That means, let me again repeat, if none of the Ei's which are incident on the vertex Vi is in the Cj cycle, then all the terms of this equation will be equal to 0, and therefore the addition will be equal to 0, and therefore the ijth entry of the AB transpose will be 0. So in that case we are done. Ijth entry is 0. Now let us consider the case where there exists at least one edge which is incident on V1 and the same edge is in Cj cycle also. Okay, now suppose that some edge, say ER, is incident on Vi and the same edge ER is also in the Cj cycle. Then in that case, this vertex Vi will be also in Cj, because we know that if a cycle contains an edge, then it contains both the endpoints of the edges also, and because V1 is an endpoint of ER, we have that V1 also belongs to Cj. Now because this Cj is a cycle and V1 is a vertex, the cycle will exit this vertex by some other edge, say Es. So there is some another edges, let us call it as Es, which is also incident on Ei and which is also in the cycle Cj. Now note that apart from these two edges, Er and Es, there are no edges which are incident on Vi and both the edges are in Cj cycle. That means Er and Es are the only edges which are incident on the vertex Vj and both the edges are in the cycle Cj. So that means in this star equation, in this equation star, only two terms are non-zero, all the rest terms are 0, and therefore the addition of all the rest of the terms are 0, and only two terms that are non-zero are this term and this term. Now we have to prove that the whole equation star is equal to 0, and therefore we have to prove that this addition is equal to 0. We know that both the entries are not 0, but we have to show that the addition is equal to 0. Now let us fix any orientation to Cj. That means we can give it clockwise orientation or anti-clockwise orientation. I am taking clockwise orientation to Cj cycle. Then there are 4 possibilities for Ei. I know that the vertex Vi is in the cycle, and I also know that the edge Er is incident on Vi and the edge Es is also incident on Vi. So there are these 4 possibilities. The first possibility is that both the edges has this direction. Second possibility is the edges has opposite direction, and these are the 4 possibilities, 4 different possibilities. Now first of all, let us consider this possibility, and then in that case I have to prove that the addition is equal to 0. Let us see that. Now AIR. Now AIR, we know that AIR is the ith entry of the incidence matrix, and we know that the ith entry is equal to +1 if the vertex Vi is the initial vertex for edge ER, and if the vertex Vi is initial vertex of is terminal vertex of ER, then it is -1. Then here we can see that the edge ER has terminal vertex as Vi, and therefore it is entry is -1. And also consider AS, then AIS. Then AIS is equal to +1 if the edge ES has initial vertex as Vi, or else it is -1. But we can see that the edge ES has terminal vertex as Vi, and therefore that entry is also -1. So we find out these 2 entries. We found that both the entries are -1. Now let us find this entry BJR. Then by definition of circuit matrix, we can see that the edge ER is in the circuit, and therefore it is a non-zero entry. And also we have fixed the orientation as clockwise orientation. So the orientation of the cycle is in this form, and you can see that the orientation of the cycle and the direction of edge ER are same, and therefore it is +1. But you can see that the orientation of cycle and the direction of edge ES are opposite to each other, and therefore ES has -1 entry, and you can see that the addition is 0. Thus you can see that both the terms are non-zero, but still the addition is equal to 0. So if this is the case, then we are done. Now similarly we can prove that if this is the case, then also addition is equal to 0, and if this is the case, then also addition is 0, and in the last case also we can prove that the addition is equal to 0. So we proved that in any of the case the ijth entry of AB transpose is equal to 0.